The scientist, Adelberg Ames, has developed some ingenious experiments. In this figure, the two ends obviously are parallel, but the two sides are not parallel because the two ends are not the same length. This figure we call a trapezoid. Now let's remove the cover. Are you a bit confused? Well, all we've done is cut some holes in the figure and painted it to look like a window frame. But maybe you say, well, you can't fool me. That's still a trapezoid. Well, it's still a trapezoid, all right. But now let's revolve the figure and see what happens. Does the window frame seem to turn, then stop, and reverse direction? Well, such is not the case. It is revolving continuously in a clockwise direction. Now, even when we know this, the illusion still persists, and it looks more like a window all the time. Well, maybe you need a reference point. See if the cube will help you follow the edge of the trapezoid all the way around. Watch closely now. Doesn't help a bit, does it? Not only does the trapezoid still oscillate back and forth, but the cube actually seems to take off and go floating through space. Now, it doesn't, of course. Actually, the cube has been firmly attached to the edge of the figure all the time. Now, an iron bar should make a good solid reference point. Let's see what happens now when we rotate the window. Of course, we know that the revolving window frame cannot possibly bend the iron bar or cause it to cut through the window frame. But this knowledge seems to be of no help at all. The illusion of an oscillating window still continues. From earliest childhood, it has been our experience that windows are rectangles and that all sides are parallel. Your eye sent an accurate image to the brain, the image of a trapezoid painted like a window. But your mind said, ah, that's a window. And rather than give up the idea that all windows are rectangular, your mind accepted all sorts of improbable things, blocks floating in midair, solid bars bending or cutting through solid matter without even leaving a hole.